All right. So, where do you want me to start? You probably know. Do you know how to do your face wheel, right?
Yeah.
Or you want me to go over it? So you sure you can do the face wheel with what you got? Okay. So we're gonna start at
The G01 or G01.
We'll start at tool 2 then. Okay. 3/4 inch, 3 flutes. Right? So we go, what do I do to change my tool to the tool I want? Remember?
Sorry.
All right, let me see how to do
And then we got. Should I just keep all the G0 and just change like the X and Y and stuff?
I was going to go over how to do this one. That way you can do yours this weekend. And then I'll go over yours with you on Monday before you run it if you want.
Oh, okay.
Does that make sense?
Yeah.
I don't want you to understand how I got this. I don't want it to look like magic.
No, I think I have more of a grasp than what I was whatever telling me.
So how do I do what's my tool change line going to be?
M6 and then T2.
Correct. So let's go through how to make this. And then, so we have the G0, G20. I have not
90 and then 90.
I'm not writing all this stuff. I'll do this, okay?
Yes.
And then what's next?
G54.
No.
Oh wait, no, it's the. It's the M3S.
S something?
S3 3100. Yeah.
And then what?
And then it's the G54. Or your opposite, I guess.
So now we got to decide where we're going to start.
Yeah, and then
So at the top I said X0, Y0 is in the center of the stock. So X0, Y0 is right here.
Yeah.
So you can do that, you'll have to do the math. And it also depends on, so you can do cutter comp in this. The way I usually teach this is I have everybody do one manually and let them use cutter comp on the other one.
So you can use cutter comp?
You can. And if you use your cutter comp, you can just program the line.
Of the straight edge?
Yeah. So this one I didn't do that. This one I did it the other way. So here's what we do. How far is it from here?
1.5.
1.5 from here to here, right?
Oh, from here to there, from there to there is, no, that's 1.25. Wait. Oh, no, 1.5.
Guess I could do it there.
1.4.
But if I do it over there, you can't see it. So let's do it right here. So you can see it on the TV. On the recording. So you have your part like this. Right?
Yeah.
X0, Y0 is right here. So now you said, so this is 2.5 divided by 2, so how far is it from here to here? John? Center to the edge.
1.25.
Correct. And this would be your x, correct?
Yeah. Yes.
It's a horrible x. Okay, so what do we have in y? Y is that way.
Why would we? 750. No way.
From here to here.
750.
So if we know this is 250, and this is 250, it's even all the way around, is what he's trying to tell you. So an inch and a half minus 250 minus 250 leaves you with
Just an inch.
an inch. Then you divide that by 2 and you've got a half inch.
Okay, so.
So this distance is 0.5. So then, on the starting point though, we don't want to start up here on the stalk. We want to start out here, right? So, let me draw that around here.
So then you'd what?
Oh, the whole thing divided by 2 would be 1.5 for this distance,
Would
correct?
you move 0.25 up, or would you?
Hang on. So center it here over here is your 1.5, correct?
Yes.
And the center here down this way is going to be 1.5 divided by 2. That's that 750 you mentioned earlier.
Yeah.
And then my cutter is a 3/4 inch end mill. So you're going to want to move at least 3/4. So that'll get you 750. We'll just go by what I put. But you see, I want to start down here is where I started. I started down here like I always do. You'll find out I'm like a robot. I always start in the same spot. I usually stop in the same spot because it just makes it easier to program that way. So the point I used down here to start was x negative 1.625 and a y of negative 1.875. And that was just the random place that I picked off the part to start. Follow?
Yeah.
So G54 x negative 1.625 and a y of negative 1.875. I'm going to delete this so that you don't get confused. I'll probably leave that. And then we'll roll up. We'll go down here. We're going to draw a line right here. And we'll draw a line right here separating all this stuff so that you don't get confused, okay?
Oh, okay.
Does that make sense?
Yeah.
That way you can see the difference.
Can't you zoom in and out though?
On what? The camera?
No, on the screen. Then you just picture.
Oh, you can pinch it?
Yeah.
Yeah. I'm trying to leave it big so you can see it on the camera.
No, yeah, I was just gonna say you could zoom in whenever you're going in for like a diagram or something like that, and then that way it's smaller than the background. You can still see it.
So we got our start point. Then we do a G. What's next?
43.
Are you cheating or are you telling me out of your head?
I definitely cheated.
A Z, I put 1 inch above the part.
And then after that.
And then G01,
G01 and then.
which is a linear move, right? And an AZ of 0.1, so we're just dropping at a feed rate instead of crashing into the vise and wrapping. Now I do a Z of negative 0.2. Mine I do a Z of negative 0.3. Because when we did our face pass, we took off how much?
You took off 25.
It says on here I took off 50.
0.25.
It says on here I took off 50 on the face pass. So this block's an inch and a half to start with, right?
Well, yeah.
So I take 50 thousandths off and I save the other 50 for the other side. So you face mill the 50 off the top. Your step right here is 1/4 of an inch, so you have to put that 50 that you took off the top and add it to this number.
Okay.
Because see, the stock used to be up here, right?
Right.
And I took 50 thousandths off. So the 50 thousandths I used in my face pass, you have to
So
add
that
this.
so that little go down 2, then go down 3. So now you're right above the part, right?
Well, no, this -3 is this line right here. Right here.
Oh, that gets to there.
Wait, so if I've got my part, my original block, okay?
I see that you shape your face middle.
Your original block, you face mill off, and this is gonna look totally outside. You took off 50 thousandths like this, right?
50,000.
And then right here, it says we need to go down, what, 250 more?
Yes.
So your your Z0 is here. So when you go to cut that step, you have to add this 50, or you're gonna have a 200,000 step instead of 250.
Oh.
Because you have to go down as if this was still here. Follow?
Yeah.
So you go down to an X of -3. So this is -3 from original stock. From C0 top of stock. Does that make sense?
Yeah. No, yeah, I get
Try to write a note in here so that you don't, so that you look at this later, it still makes sense.
it. No, yes. As long as the sound's working, I should be able to.
So then over here, I also turned on, I did an M8 to turn on coolant.
Yeah, on that back side, you didn't really have an M8 for a couple, but in the middle.
Sometimes I don't do that so you guys can see what you're doing. Sometimes I
I was like, oh, the coolant's not turned on.
Better to turn it on by hand so that you can still see what's going on.
Yeah.
So M8, so there's that line, correct?
M8, and then, oh, that's when you start the G0.
So G01,
Or, yeah.
and I did a Y of,
It was a Z of, oh, wait, no, it's a Y of
0.25. And a feed rate of 45, which is, who knows if that's right or not, right?
It's not.
So here's what we're doing. Come on, move up here. I'm gonna draw this part again. Hopefully I don't confuse the donuts out of you. So here's the center. Here's the outside. And I comp this, instead of using cutter comp, there's a way that you can comp it in your head. You basically manually comp it all the way around. If you don't understand, I'll draw it for you too, because I think it makes it look even more obvious. I can show you what's going on a little bit, okay? But what we're gonna do is we're gonna program a line that is, our end mill was what, 3/4?
Yes.
So I want to program a line so that here's my 3/4 inch end mill, right here, okay? And here's the center of it. So what I'm going to do is I'm going to do a parallel line that I'm going to program the same as this one, around like this. So my cutter follows the line I programmed.
Yeah.
That way you don't have to have cutter comp. So I want the radius of the cutter distance to be this far away. So this would be the radius of your cutter.
375.
Let's do That's as good as I'm gonna do, man.
Great.
Huh? So, first things first, we want to figure out where these points are. You saw me draw them out the other day, and it's similar to doing that. We really don't care about the outside as long as you know you don't start on it.
Yeah.
So then I can just draw a new box like this. And then I can take and go from here to here. And you told me earlier that that was 2.5 divided by 2, which would be 1.25. Right? And then this way, what, a half an inch?
No, that was, yeah, half inch.
So then what we want to do is we want to add that radius of the cutter on so that you're out here. So you want this to be the radius of your cutter. So 750 divided by 2 is?
375. 375.
Right today. And this one would be the same thing. We would add another 375 down here.
Oh, you're saying add?
Because you've got to be,
Yeah,
cutter
yeah.
set here like this. Okay? So that's your cutter. So I want a line that goes parallel to this one all the way around. That is 375 thousandths away. Okay?
Okay.
So to get this dimension, it's easy. You just add that to that. So 1.25 plus 375, 0.375 is what?
I'm sorry, let's do the math.
0.375 plus the 1.25.
Oh,
Use your phone if you want.
I know what was back there. 1.575. No, wait,
So,
1.6.
here you go, Todd. 1.250 plus 0.375. 5, 7 and 5 is 12. Carry the 1, that's a 6. Correct? Not.
Yeah.
It's easy to do it that way, isn't it? So your x is 1.625. So now we gotta figure out y, so that's a little easier. 0.375 plus the half inch. You can probably actually do that one in your head, right?
What? Oh, 8, yeah,
875.
800. Yeah.
So that's gonna be our y going this way.
Yep.
And then we take our radius, which is right here, right? Take the radius,
Right.
250. So, I'm gonna rewrite this down here, I think. We'll do x of 1.625. And we're gonna do a y of 0.875. And these are diameters. This is in half, so we'll go DIA of rectangle. And then, or I should really do width. Length and width will make more sense later, right? So this is the width of your new rectangle. This is the depth, or however you want to put it, in y of your rectangle. Are you following me? You basically redrew this and we made this bigger, right?
Oh, yeah. Okay, yeah.
I think I just did to you though. Because That's an inch divided by 2 plus half the cutter, so this is actually, yeah, I fibbed. This is from your 0, 0.
Yeah, that's what I thought.
You didn't catch me.
I was just a little,
You can question me, it's all right.
I'm not gonna lie, it was kinda hard.
So this is
I definitely zoned out.
your distance in X from 0, 0, or from X 0. That make more sense?
Yeah.
That's this distance from here to here.
There,
So it doesn't look like magic anymore, right? This is your distance
From,
in Y from
you could just put Y 0.
Y 0. Follow?
Yeah.
So now we have those. So now we're to the point where I would probably draw me with. So we're gonna go. You're gonna see I was not an artist. So now we know our X from here to here is our 1.625. And we know our Y from here to here is 0.875. Now we also know if we added that radius, obviously this radius gets bigger because we're doing a bigger way around, right?
If we added the,
Since we stretched out the rectangle, you've got to stretch out the radius with the rectangle. Does that make sense?
Yeah.
So we take this radius right here. How did I do that?
zoom in.
The other way.
Anyways.
So we take this distance right here, and we do the same thing, we add half the diameter to it. So we take the original radius, which is this radius right here, okay?
Yes.
And it used to be 0, or it is on this part, it's 0.250. So we add half the diameter of the cutter, 0.375. You got a 5, a 12, 5, 6, is that right? Correct?
Yeah.
You understand how I got there?
Yeah.
So now our new radius for this one is so that's this radius.
And then it's put 25, right?
So what did we just do? We just made a box around, we basically made an identical
Didn't
parallel.
it- So it just went a little bit bigger though, like from where it was?
Yeah, it's half the width of the cutter, each way bigger, all the way around.
And then,
So your original box is in here like this. Okay? And we drew
yeah,
another one.
that's like the line that the, that's like the
That's,
center
this
line
is your
of the
print
cutter,
right here.
Right, the center line of the cutter, right? Just the
Yeah.
solid line.
The dashed line is your print.
Yeah.
This is your cutter path. My shirt needs to stay away from that.
So, quick question then, so like on this one, it's got the two radiuses right here, I would have to do that.
So, at this point, all we have to do is find our little points, right? We know everything else we need to know. So, the easiest way to find those points is, we know what this x is, right? Because this x is gonna be the same as this distance?
Yeah, but, yeah.
So this x is 1.625. We know what this y is right here, because it's the same as that, right?
Yes.
0.875, and that's y. So now we have to find the other two, because we're not sure what they are.
Wouldn't the X on the top one be the same as well?
Yeah, all four. I'm just doing 1/4.
Okay, right.
I'm trying to finish 1/4 because then I think it'll all make sense to you.
It's making sense now.
So now, this is our radius, correct?
Yeah.
So, what I need to know is, so the center point of your radius is gonna be in here, because you're swinging that way. So I need to know what this distance is here. If you look, it kind of makes a box. So if I take this radius off of x, it'll tell me what this x is. Because I want to know the point where the radius starts and stops.
So.
Okay, so here's our x. We determined it right here. We figured it out. So now I want to know what the x is over here where my radius starts. Or stops, whichever way you want to look at it. So you can subtract the radius from this. So 1.625. Yeah, exactly. 1.625 minus 0.625. So this is our radius. Gives me 1 inch.
So is that the x then?
So that's this x. So this x will be, and I always put the x above, so let me delete this a little bit of this. Or delete the whole thing. So x of 1.000. Now if we're down here, so if you're over here, x is what? Positive or negative?
That's positive.
So if you're over here, y is what? So we need a negative sign right here. Now the same thing with your y over here. You take this y, which is 0.875,
and
you subtract
y would be 2.
So y is 250. So that's what your y is up here.
That's crazy.
And it's negative 250, right?
Yep. Negative, yeah.
So now we know one corner, so we know every corner, correct? Because you just take the numbers, you go around, and you flip your negatives and your positives as you need, right?
Yeah, that's just like the one class in high school, geometry.
Now, does that make sense like that?
Yeah.
So if I take it and I draw it in Fusion, let's see how long it takes my Fusion to open. I should have had it running in the background.
No, I mean, I think I understand.
Yeah, but this is cool. I'm going to show you this, because when Justin did this to me, it made a lot of sense. I was
That's
trying
kinda
to.
how I think, like, whenever I'm looking at, like, the thing, I kind of, like, imagine it already, like, building a machine. Is that what this is about to do?
What?
Is, like, show you.
I'm just going to draw what we just did on top of it, and you'll see it.
I'll find it out, I guess.
Because it made the light bulbs in my brain come on. I was struggling with this one day because I was tired, and you should never program when you're tired or out. It doesn't turn out well, not even for me.
I don't know, it's turned out, well, a couple times for me. Considering I'm back here this semester.
So did you like the way we went through your program the other day in class?
Well, yeah, that was good.
I can do that.
But I feel like I kind of want to try and write it myself.
No, I want you to try to write it, and then I'll walk through it with you.
Yeah.
If you want to do that, I'll do that with you. So this is project, that's this one. Where's the right model? I don't know what it looks like, John. Looks like that with one hole in the middle. So that'd be, oh, it's right here. Make sure I get the right one. Get some more room. Go to top view, like this. Okay. Now I gotta go back to, I'm already in design. Create. So now, we said our cutter was 3/4, correct?
Yes.
So I'm going to draw a circle. That is 0.750. Or maybe I'm not going to draw a circle that's 0.750. Let's do this the hard way. And we're going to do this to this. Okay, so there's our cutter, right? Huh?
So that's what I was talking about. Kind of like a simplistic. But yeah, that's correct.
I'm going to do a shell of this, and I want to go this way. So half the cutter was, help me out, John, I don't remember. 0.
Oh, the cutter? Oh, what?
Half the cutter? 375?
375.
Okay.
Yeah,
I thought it.
Oh, that's fine.
Now we're going to put dimensions on here.
What's this app called?
What I'm in right now?
Yeah.
Fusion. It's not an app. It's a cam software. I'm just trying to label some of this stuff so that you can see.
Right, Y at 1. And then X, Z. Yeah.
So see, this is what we're doing. This makes more sense than me sketching on the board. So your cutter's out here, right?
Yes.
And your cutter's gonna go all the way around like this?
Wait, on the left side, does that say 450?
That does, it's the total distance of that straight line. So if you divide that
Oh,
by 2,
okay.
it would be your distance from center.
Okay, so you can go Y. Oh.
Here, let me get rid of it, and I'll redo that one. I can do it like I did the top one. You see the top one that's an inch?
Yeah.
Isn't that what we come up with?
An inch. Yeah. Yeah.
So here, I can dimension it from center line. So this distance from here to this point right here, not crooked. So now you see it's 200 thousandths, which is that whole width divided by 2. That's how far you are from the center.
Right.
So you see how that all laid out like that? You see where your radius swings from, because it shows you on here. So my new radius swings from the same spot my old one does. It's just this much bigger because it passed out here. So we want to step into it. You want to go up. You want to go all the way around. And and then you wanna come off, but you don't wanna leave a little hook down here or something unfinished, right?
Yeah.
So we loop around this corner and then we finish up here somewhere.
But, so for this one, you'd start in the corner.
Pick a corner.
Go
Yeah,
up.
you can really start anywhere, but it makes more sense to start in a corner. If you wanted to come up here like this and come down into it and loop around and go this way, then you could come off like that.
I was just gonna say, I'm gonna start at the bottom left and then go up.
For the sake of doing it fast and for the sake of doing it easy, I would draw it just like I did,
Yeah.
and then just manipulate your numbers. So they're right. The hardest part is laying this out right. That's what I wanted to draw, like, because we got the same exact thing I had on the whiteboard, correct?
Yeah.
But this way, this will be on the camera and you can pull it up and see it later. You can see how I got everything I got, and you can see an example of the cutter.
Yeah. It's not that, egg shaped.
So now all I gotta do is not save this and it'll go back to the way it used to be. Eventually.
If you just swipe with 3 fingers sideways, I think it'll pull up. On the laptop. Oh, wait, no.
Yeah, I could have done it up there. I just did it while I was sitting here. So see this distance right here?
Yeah.
That should have been the same as we had up there, and this should have been too. If we did the math right.
Oh, right. On there it said 2. It did say 2, but it didn't say 2.5. Or 0.25. But maybe, you put something in for it wrong. Because it looked like it was a little bit thicker than what it.
I also didn't look at that model. I know this program runs right.
Oh, yeah, I just ran it, so.
1.625.
I know it runs right too.
Negative 8.725. That model, I just drew it off the model. I didn't look at what the dimensions were. It was in an example.
All right.
So, you got this all kind of memorized in your head or not?
Nah, I'll go to the video if I don't.
Well, write these dimensions down so we can go through the program. Just draw that little sketch and make sure you have this part right here. Make sure you have these numbers here and these numbers here so that we can write this program.
Just go back up first.
Oh, you're not done yet?
Yeah, you're good.
So now, we've got our starting point. Let's go back to the starting point. So now you know how I got the starting point, right? So G54, I'm gonna write some of this again. Touch it. X of negative 1.625, Y of negative 1. So we're off the bottom left-hand corner.
Yep.
And then, so I don't confuse you, I'm gonna do G43, H2, Z 1.0, G01, Z 0.1, feed rate 25. Z of negative 0.2. Z of negative 0.3 and 8. So we're dropping down to the right depth, correct? So then
Yes.
the first move I do is, so we're down here, I want to go up here till I get to this first point where my radius turns.
So plus, 1, or plus 875,
You
right?
got to do a G01, and we want to go to this point, not all the way up here, but this point on our shape on the outside.
Right, so we have to go from Y.
So you go a Y of 0.250, because it's our new shape that we did.
Right.
That's where you got that number, remember?
I was still writing it down.
So this is off of our tool path that we came up with. Is where this came from. Okay? So now if you had your book, got it. Look up G0 or G02 and G03 and tell me what the difference is.
Linear interpolation, motion used for machining metal.
No, G02 and 3.
Oh, circular clockwise and 0
Okay. Makes sense? So which one do we want to use to turn that corner at the top and go?
obviously 0 2, right?
But I understood what you think I'm pulling about this guy.
Yeah, because I'm not gonna lie, I was a little confused on what move does little.
I know. So G02
That's fine.
goes clockwise, okay?
Yeah.
So if unless we're doing something like a shape like this, if we're doing a shape like this, where you go around, we always go this way because we don't want a conventional mill, so we always go, we start here and go this way, correct?
Yes.
So this is gonna be your straight moves are G1. Your radiuses are gonna be G2s or 3s. But in this instance, we wanna go clockwise, so it's gonna be the G2. So we don't need the G3, right?
Oh, yes.
So G1, this is gonna be a G2, this will be a G1, this will be a G2. That doesn't even look like a G. This is actually supposed to be a straight line, so this will be a G1, G2, G1. Does that make sense? So you just sit there and flip back and forth.
Okay.
Now, if I wanted to do a G3 for some reason,
Understandable.
but, so,
Linear.
not to confuse you, but I want to show you what the difference here. So if we had a shape that did something like this,
Sorry, only moments.
that's a horrible drawing. So you try it. We'll do a box. And then I'm going to do a inside radius like this.
So like that?
And then I need my eraser. Erase part.
In that case, you would go G0 or G3, right?
So yeah, see this one's an inside corner?
Yeah.
So if I turn, let's make it kind of like this. So here would be a G1.
Yes. And then a G2.
Here would be a G2 to turn that way.
G3 to go back up.
Uh-huh.
And G.
Makes sense? Makes sense?
Yeah.
What you laughing at?
Nah, I
Do you
just
want to know?
I said Gia.
Gia? Like
it's
Gia
something
Pet,
that-
except Gia?
It's like G. I can't really explain it. It's something. I met a guy on PlayStation who was like funny as hell, and he was like Gia, like instead of saying yeah.
So, okay. Up here we have our G01 Y of 250. So now we're to our first radius, right?
Yes.
So we do, I'll change this back to everything. So now we do a G02, if we can put it back on the pin. G02, X of negative 1.0, Y of 0.875, and I did a R of, R's the radius you wanted to make. 625.
So when typing the code, that's the code that you type.
This would be your life for that
The
one.
line. I mean, yeah.
Give you a little hint.
Oh, I
as you
can look
put-
right here.
So if these points do not land on this radius, it's probably going to throw an error.
Hit error in the machine.
Yeah.
Okay.
Not necessarily.
No, it might not. But I'll look out for it.
So then we go straight across the top, right?
Yes.
G01. So where's my X stop?
The X will stop at 1.6. Or wait, no, it'll be just 1 inch.
Yep.
Inch.
So then what I do next?
1 moment. Alright, then we do G2. And then, Y,
I would just, you can do Y first, but I usually do X first. So let's.
oh, okay, so then an X of, 1.62, or 65.
What's my
And my Y is negative, 250.
You sure it's not positive?
No, it's negative. Oh, no, it's positive. Okay, I was. I didn't do that for
And then my R of 0.625. Okay?
Right.
So now our next line is going to be a what?
Down one's gonna be G1. And then you're gonna go to X of, oh, the X will stay the same, but you'll just go to Y, negative 250.
Don't we have to put in there what's changed?
No, you just have to put Y in.
Yeah.
Yeah.
Whatever changes.
And then G2. Or Y? Yeah, G2. And then, X of 1, positive 1, and then Y of negative 875.
And your radius.
And then G1. Oh, yeah, radius. Wait, so what happens if you would forget the radius? Would it just cut straight?
It doesn't know where to go at that point.
Okay.
I mean, you can bubble out a radius, so you can make a bubble. Really the best way to not mess this up is there's a way to do it with like IJ. It's in your book. If you do that, it's harder to mess this up because you can get the wrong one, but if it cannot do it physically, then it'll throw a code and usually stop it.
Yeah. And then back to G01.
G01, X of negative 1.0. So now I'm over here, right? But I told you we had to turn the corner and come off up there somewhere.
So yeah, so when you just do a
G02.
2 again, and then X of negative 1.625, and then negative 2.
0.625. And then that leaves me with one more G1. So I just ran off the other side of the part. I did a G01, Y of probably the same point I started at, 1.875. Just opposite, so I started down here, so I stopped way up there.
Yeah, that's what I noticed.
See, this is why I wanted you to run my part and then come in here, because you see the machine do it. And now I'm going to show you why the machine did it and how.
Yeah.
Does it help you understand?
Yeah. I think so.
See, 1.0, M5, G91, you know how to do all this, right?
Yeah.
G28, C0,
We got
G28,
49, X2,
49. We don't like doing X0 because then the table moves in the corner, so we'll just do a Y0. Keep the table out of the cubby hole in the corner. So if I did X0, the whole table moves over.
Yeah, there's a couple X zeros in this.
Trying to teach you the differences that way by physically showing you.
Yeah. I was like, damn it, I should have looked at that.
He's like, I should have went delete, right?
Yeah. There's probably a shortcut that.
G90,
Find what? Oh, look, there it is.
Gen01.
Oh, but I can't really do all X zeros. Can't get rid of every single X zero. There might be an X zero
Yeah, there might be an X0 you need.
for the whole. Yeah.
So you understand the spot drill and the drill and the ream, right?
No. Pretty sure I do.
You've already drilled and tapped, you can drill and ream.
I've already drilled it. Oh, so like whenever you're probing the tools, like you like make sure you know
The estimated height.
no, not well. It's kind of that area I think, but like you change it from like an end mill to like
The shell mill to the mill to drill bit,
that
tab, that stuff, yeah.
Yeah. So what would you do for a reamer?
You can just do drill bit.
Okay, I just did it as a.
That's just kind of so the machine knows what it's looking for. Plus, like if you put in the probe, you can go in your offsets and you can say delete all offsets except the probe, and it'll wipe out all your offsets except the probe.
Oh, really?
So you don't have to zero them out. If the probe's labeled correctly.
Should we calibrate the probe?
I'm fixing to go out and mess with them all here in a little bit, because we've got a problem, because my class, my 111 class, has heights like all over the place, and I need to figure out why. So let's go over the other half of this real quick.
Yeah.
Do you want me to make, here, let me just stop this video and I'll make a separate one for the next one.
Okay.
And I'll get a different print and I'll get a new whiteboard.